In this video, we're going to deal with some of the calculus for sine and cosine. Long story short, when you differentiate sine, you get cosine. When you integrate sine, you get negative cosine. Or we might say if you integrate negative sine, you'll get positive cosine. Put the negative sign on whichever side of the equation that you want here. When you differentiate cosine, you get the opposite sine function. When you integrate cosine, you get the sine function. And you can see kind of here that the top one and the bottom one, you see those are inverses of each other. If you take the derivative of sine, then you'll get cosine. But if you integrate cosine, therefore, you'll get sine. And these two actually go together as well. Differentiate cosine, you'll get the opposite sine function. If you integrate sine, you'll get the opposite cosine function. These two go together as well. We're going to essentially lean on these truths as we go through and talk about things in a little bit more detail. The derivative of f of x is equal to a sine bx is, there's a function, bx right there. Sometimes b is 1, isn't it? And there's a function right there. So basically, when we differentiate this, we have to use the chain rule. And the chain rule says there's the constant. Now we need to differentiate sine of bx. Well, the derivative of sine of anything is the cosine of that something. And then when we use the chain rule, we have to then differentiate the function on the inside. Well, if you differentiate that with respect to x, you get b. So when you have simplified this, you get a b cosine bx. So let's differentiate this. I've left a little space here so that we can show that anytime you use the sine or cosine function, basically you have to use the chain rule whenever you're differentiating, even if it doesn't look like it. It doesn't look like there's a function within a function, but even look at this. Isn't x a function? If you graphed it, you'd get a straight line with a positive slope. X is a function. Well, the sine of x is also a function. So anytime you have sine of anything, it's a function within a function. When we do this, we're going to say, all right, the coefficient 6 is not going to change. We differentiate sine, we'll get cosine of x, and then we have to differentiate x. Derivative of x is just 1. So this is nothing more than 6 cosine x. How about here? The constant of 8 isn't changed. The derivative of the sine of anything is the cosine of that thing. So I'm going to put cosine of 2x. But then we have to take the derivative of what's inside here, which in this case is 2. See, up here it was only 1. Here it's 2. So when we simplify this, we're going to get 16 cosine 2x. And if this were negative 8, if there were a negative sign right there, let's just pretend, well, then there'd be a negative sign in front of this one. What if you take the antiderivative? Well, with the antiderivative, when you integrate sine, the constant c is going to stay the same. When you integrate sine, you get the opposite of cosine. So I'm going to put that negative sign out there, and I'm going to say cosine of that thing. And then when we were integrating polynomials, we had to divide by the new power. It's kind of like that here. We have to divide by the derivative of what's inside here. So that's the pattern that we follow there. Let's try this one. If we integrate this, we integrate f of x dx. That constant, negative 7, stays the same. When we integrate sine, we get opposite of cosine of x, and then we have to divide by the derivative of x, which is just 1, and so that doesn't come into play. So here we're just going to get 7 cosine x. If it's an indefinite integral, we should probably put a constant c after it, like that. Let's try this one. When we integrate this one, the 12 is going to stay the same. When we integrate sine, we get opposite cosine of 3x. And then we have to divide by the derivative of the 3x, which is 3. When we're done here, I think we're going to have negative 4 cosine 3x. And if it's an indefinite integral, we should put a c there. If it's a definite integral, then we don't have to put that, obviously. What about cosine? Well, when you differentiate cosine, you get opposite sign. What we're going to get here is the constant e. Differentiate cosine, that's going to give us negative sine of this f times x thing. And then we have to multiply by the derivative of this, which is f. So when it's all said and done here, I think we're going to have negative e f sine fx. I'm just using letters here to indicate constants. So let's try this one. If we differentiate this, let's leave the negative 5 the way it is. Differentiate cosine, you get negative sine of x, and then you multiply by the derivative of x, which is just 1. So in this case, we just get 5 sine x. How about here? Differentiate this. The 10 stays as is. Differentiate cosine, you get negative sine of that. And then we have to multiply by the derivative of this, which is 2. So I'm seeing negative 20. Did I do that right? Negative 20 sine 2x. Just like that. Let's finish with the antiderivative. Antiderivative of cosine. The g stays the same. The antiderivative of cosine is sine of whatever it is. And then when we take the antiderivative, we have to divide by the derivative of what's inside there. Kind of like that. That's the pattern. All right, let's try these examples here. Let's integrate this. We're going to leave the 15 the same. When we integrate cosine of 3x, we get sine of 3x. And we have to divide by the derivative of 3x, which is 3. I'm seeing here negative 5 sine 3x plus c. One more. Integrate this. I'm going to leave the 3 as is. When we integrate cosine, it's sine of x. Then we have to divide by the derivative of x, which is just 1. So I think 3 sine x, let's put a c there. And that's how you do that.